With the next problem, a particle moves along a line so that at any time t, its position is given by x of t is equal to 2 pi t plus cosine of 2 pi t. And first we want to find the velocity at time t. So v of t is going to be the derivative of 2 pi t is just 2 pi. And then the derivative of cosine 2 pi t is going to be negative sine 2 pi t, then times the derivative of 2 pi t, which is just 2 pi again. So altogether this gives 2 pi times 1 minus sine of 2 pi t. That would be the velocity. Now for the acceleration, I'm not going to use the factored form. And I'm going to take the derivative of 2 pi, which is 0, the derivative of sine, which is cosine. Well, I want the derivative of negative 2 pi sine of 2 pi t. And so I believe that the final form comes out to be negative 4 pi squared cosine of 2 pi t. Then we're asked what are all the values for t greater than or equal to 0, less than or equal to 3, for which the particle is at rest. So what we're looking for is where v of t is going to equal 0. And v of t will equal 0 whenever 1 minus sine of 2 pi t is equal to 0. Or sine of 2 pi t is equal to 1. Now we have to think about where the sine function is 1. And sine will be 1 whenever sine of x will be 1 whenever x is pi over 2, 5 pi over 2, 9 pi over 2. So what we have to do is find out when is 2 pi t equal to pi over 2, 5 pi over 2, 9 pi over 2. And so I get a number of values here. I solve a number of those equations. I get t equals pi over 4, 5 pi over 4, 9 pi over 4. At 13 pi over 4 I've gone beyond 3. So I don't include that solution there. So I have three values, t equals pi over 4, t equals 5 pi over 4, and t equals 9 pi. T equals pi, excuse me, t equals 1/4. I keep making that mistake. T equals 5/4, t equals 9/4. So those are the values between 0 and 3 for which time is equal to for which the velocity is equal to 0. Now part D is asking what is the maximum velocity? Well, maximum velocity or minimum velocity for a differentiable function, a smooth curve, will always occur when the graph has horizontal tangents. So if we're looking for where the velocity graph has horizontal tangents, we should be looking at where its derivative is 0. So we should find out where the acceleration is 0. Now again, there could be relative maximum or relative minimum points wherever the derivative is 0, or neither. It could happen. So what we have to do is find all those places and then evaluate the original function or evaluate the velocity function at those places and see which one has the largest value. And the acceleration function will be 0 whenever cosine of 2 pi t is 0. Once again, remember that cosine is 0 whenever x is pi over 2 and 3 pi over 2. So cosine is 0 at 3 pi over 2, but sine is only 1 at pi over 2. So it would be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. 2 pi t is pi over 2 when t is 1/4. 2 pi t is 3 pi over 2 when t is 3/4. 2 pi t is 5 pi over 2 when t equals 5/4. Now a question is raised as to whether or not we should be working with the same limited domain as we were in part C, or if we're working with infinite domain. And if we kept finding values following this pattern, then within the domain from 0 to 3 we would have all these times at which we could possibly have a maximum velocity. 1/4, 3/4, 5/4, 7/4, 9/4, 11/4. And if we started testing some of the points, remembering that we're plugging back into the velocity function, and you'll see that you get these values, the maximum velocity is 4 pi then. And it doesn't matter what the domain is.